Hi again. In this episode of the Razorback screencast, I think we're going to focus a little bit on these pneumatic pistons right here at the rear of the bike. So these power the robotic kickstands, and in the past we sort of roughed them out, but we never really did much with them. I know that I do have a sort of a zero angle established, so that if I were to reduce the pitch of this object to 0, we do get sort of an intended resting point for them. But other than that, we haven't really done much. So let's revisit these and sort of think about how they're going to function and what parts are missing. So far we have a shaft that sort of runs right through the machine just behind the engine block. It runs right between the frame and the engine. If I were to move a part of this, we can see that really clearly. And it sort of actuates the kickstands. No big deal. The other part of this that's sort of missing is the actual pneumatic ram. What I have here in place of it is just a simple cylinder. It doesn't really do it justice. What we'll need to do is add a cap to each end of this, along with a sort of an input-output nozzle and a hose. The hoses, while not completely necessary, I mean this could be an electronic actuator or some sort of a worm gear, or the hoses could come in both at this end. I think that it's another one of those instances where adding more cabling and hoses will just make it look a little bit cooler, so we're going to do that. To start, we can just do something as simple as use some primitive cylinders to get started. So I'm going to duplicate the ram right here. Even though everything else comes with it, I'll just delete that and then just start moving it into place. The cap is going to need to be pretty squat, just about that, no bigger than it needs to be, and have a slightly larger diameter. We can also round the cap off a little bit, but maybe that's best done after. You can also just control drag down here to create the other cap. Now the lower cap I actually want to be a little bit taller. I just feel that might give us more of the look that we're going for. And because these are both still primitive objects, we can actually just adjust the radius if we needed to. But I think the radius that we've chosen is good. Now, the first thing that I feel like I want to do is sort of round the edges a little bit. I don't feel like the sharp edges work for the look that I have in my head. So I'm just going to select both of them, current state to object, and perhaps we can do the connect objects plus delete function. That way we just have one polygonal object that has both of these cylinders in it. We then want to, of course, optimize all the points so that we can work with them as solids. Let's make sure the settings are correct. Looks good. Now we can use the loop selection to select the top and the base, and then we can just bevel them. I think something around that looks good. 0.16. Let's just do 0.175. Call it round. Great. So now we can select all these faces and remove the n-gons so that they don't get away from us. And we have caps on that ram. It's beginning to look a little bit better already. Now the next step are these hoses, these cables. Now what I'm envisioning is sort of a 90-degree elbow right here at the top, maybe offset, or maybe even coming out of the side, and then something similar down here. The reason that I like that look is because we get to run a cable along this if we do that. And the other thing is this is going to pivot, so it's going to create sort of an interesting challenge. Because it pivots, our cables are going to pivot as well. So maybe we can use a bend deformer and some espresso to make sure that the cables bend appropriately when we bend this actual mechanism. So for now, let's leave it at 0, that is fully extended downwards, and start modeling. If we go to the side view, we can just start to create the objects. Well, I was thinking we'd create the splines. Perhaps we'll start with the fittings. The easiest way to create these fittings is just to start with a cube where you want them, and then to model around it. Let me show you what I mean. If I create a cube and then use the transfer function to transfer the cube to the position of the object that I'd like, which is the Ram 3 that we've created, we now have it at the exact spot where we want to work with it. We can then sort of move it outwards, and we can think of this as sort of a block that the fittings fit into. Sort of a 90-degree turn for the fittings. So we have one down there, well, one up there rather, and what we can do is we can place it in the Ram 3 group so everything stays together, and then we can sort of transfer other objects to it. For instance, I wanted to create a cylinder, transfer the cylinder to the cube. We're sort of just chaining these objects together. So this cylinder, probably 12 segments. Let's have no caps, and we just scale it down. So what we have is a piece of a fitting sticking out right there. And then we can sort of just replicate this effect. Maybe it's easier just to do it than to explain. But here it goes. If we duplicate the cylinder and then transfer it to the center of the cube again, we can then change its orientation to Z, and then bring it out the other side. So what we have now is sort of a rough-looking 90-degree bend. We can maybe scale those up a little bit, maybe independently. 120%, and we can take all 3 of these objects and just connect them and delete. So we may need to convert them to editable objects first. Connect objects plus delete. Now we have this sort of fitting. We can then come up here and close the polygon hole. I suppose we could do it on the inside where you won't see it anyway. And then we can sort of dress this cube up a little bit. What I mean is we can select that edge and do a bevel operation to give it that sort of truncated appearance. And then we can select all the edges, well, just all the edges on the cube itself. So a nice quick way to do that is to select one of the faces on the cube, and then I believe it's UW to select all connected faces, and then we can control click the edge mode. Now we have all the edges selected, and we can then bevel all of those. So I go back to my bevel tool and just bevel those really quickly, and that sort of gives us this interesting looking fitting. You know, we could also take these polygons that are still selected and just do an extrude inner on them, and that will help round out the edges of it so the Phong shading doesn't get away from us. And now we have something that sort of looks like a fitting, but it also looks quite kind of it looks more complicated than it needs to, and in this case that's actually a good thing in my opinion. So here's something that I encounter quite a lot. we now have this object, but the center point of it is at a strange location. Cinema 4D has a tool for this, and I'm going to show you how to use it. First thing is we select the points where you want the axis to be centered. We already see that the axis is currently in the correct orientation, but we basically want the axis to be right there where it's selected. There is an axis center tool, and if you open up that dialog, you can see you can center axis to all points. We'll change that to selected points, and we'll leave alignment unchecked because the alignment is currently good. I like it where it is. And then we just press execute. Doesn't look like anything happened, but when we go back to object mode, we can see that this is now the center point of this object, which is exactly where we'd like it. What that means is that it's really easy to do things like this. For instance, I can take this cylinder, I'm just going to call it 90-degree fitting, and I'm going to make an instance of it. So now we have a 90-degree fitting instance. It's currently parented to the Ram 3 object, so we can safely change its position to 0. So that means we can take it down to the lower part where it needs to be, and maybe just rotate it a little bit for style. Perhaps the designers decided to put 45 degrees between the inlet and the outlet, or the A side and the B side. I'm not really sure what they're called in hydraulics. And then we can pull it out because the axis has remained the same. So now we have these two fittings that are both facing up conveniently and sort of at a similar angle to each other, coming out of the machinery at a similar point. And I'd say this is a good place for us to be saying, okay, there's our fittings. Now because we're working in a symmetry object, the other side has the exact same thing reflected, and that's good. The next step would be to create hoses on these. Now we've created some hoses in the past, and we know that the easiest way to do it is just to sketch it. I prefer to use a B-spline or a cubic spline depending on what I'm creating. In this case, let's try a B-spline. Now, if you haven't used a B-spline much, it's actually quite cool. It's very difficult to get a sharp corner, but it's very easy to get smooth curves, and you never find yourself messing with the Bezier handles at all. All in all, it's a nice alternative to using a Bezier spline. So what we can do is, even though this is at an angle, we can just pretend it's not, and just start drawing 1, 2, 3. It takes a little bit of practice. And I'm just going to bring the spline up and over, and I'm intentionally going to make it cross directly through the axis of this pivot. This may be important to what we do in one of our future steps, but for now I'm just going to have it cross the axis and then go right there, specifically this little gap, because when we go to shaded mode we see that's actually a gap where we could potentially plumb the hoses into the rest of the machine. So that's one. We can just sort of play with these points a little bit, get a nice smooth curve, but we still want one point going through the center like that. Maybe we can move this point a little bit more close. There we go. So the next thing is to really position this in the other axis. It looks fine from the side, but if we go from the perspective view, we can see it's not where it needs to be. So what I typically like to do is pull it all the way out until it just sort of intersects the end point, and then just start feeding the points inwards. It's kind of slow work. I used to have some tools that made this sort of stuff easier in the older versions of Cinema 4D, but they don't work really well with the new version. So in general, I just sort of do this stuff by hand now. I'm going to keep looking for tools that make this easier, but for now this works fine. So I'm seeing some strange kinking here. So what I'll do is use my knife tool in line mode and just create an extra cut or two. That's the thing about the B-spline. It does behave strange sometimes. But it's not crucial that this passes through the axis. I just foresee it making our life a little bit easier when we get to the stage where we use deformers. So okay, that's accurate enough for now. The next step is just to do the exact same thing with the fitting that's higher up. In cases like this, I actually find it really easy to replicate the spline. See, the idea is that if we have two hydraulic lines running, or pneumatic lines running so closely to each other, we're probably going to want to tie them together when we're assembling the machine. So the idea that you could have two of these hoses running right next to each other right up until this point where this one branches off and feeds the top, and this one continues and goes to feed the bottom, that's a really plausible idea. Now, I typically use an interesting tool to get this effect, which is the mirror tool. The trick is that you need to mirror it. That creates a copy of the spline. It also flips it. So I either mirror it a second time or just scale the flipped copy negatively. So here's how I do that. Select all the points that make up the spline. And then what we can do is just go to the mirror tool. Make sure it's set to screen mode. And then you just drag across and mirror it. Now, what you can do is immediately mirror it again. Now you have a second spline. That's probably the easiest way to do it. And then you just delete the extra spline. This one right here. The UW shortcut works on splines as well. What is that exactly? That is select connected. So that makes sense. I've been using that shortcut for so long that I forgot what the actual command is. Now, we can select this point at the end that we don't want and just sort of delete the points running up the path. And I have a shortcut for grow selection. So I'm just going to grow the selection until it gets me up to where I want to be. Then I can just delete. So now that we have this point right here, we can put it in the end where we need it. And then just sort of use the knife to cut this spline elsewhere, so that we can have that nice bit of line running into the fitting. We probably need to select these 2 points and go to the camera view, sort of rotate it so it goes in at the right angle, and move that in a little bit. And so what we've got now is we've got these 2 lines that sort of go together, and they just split off from each other right there where they need to. But in general, they're pretty much a group, and as with most things, we like that because it might make our life easier in a bit. Now the next step is just to run a sweep along these, and that's pretty simple. So usually I like to use an end side instead of a circle. And it's a pretty big end side. I can just scale it down. And we can give it, let's see, 8 sides. Should be fine. Now, we probably want the end side to be larger than our fitting. Something like that. But now we see that the lines are too close together. That's pretty easy to fix. So we can actually just go in there with point mode and increase this gap here a little bit. Just make sure it fits and it's nice and centered. And then we can come down here, do the same thing with the base. Just make sure there's a bit of a gap. It adds to the realism, and we can add some hose clamps or something similar to make that joint look even more plausible. And then we can focus on right here where these 2 lines are too close together. Easiest thing to do would probably be to go along selecting pairs of points and just scaling them out. So I select a pair of points there, and then another pair. And you just keep going. The cool thing about using the scale tool in this context is that it's going to scale on whatever axis it needs to. More of a vector than an axis. As if you have 2 points at strange positions in 3D space and you scale them, they move away from each other. They don't necessarily move on a specific predetermined axis. And that's good for what we're doing here because these are just a pair of hoses. We don't really care what axis they run away from each other on. We just care that they get further apart. You can see that that very fact has sort of made them bulge apart, but that's okay. Now, I wanted to make sure that these ran through the center. I may have been a bit paranoid about that because now that I'm looking at it, I'm seeing that maybe I want them to go just above the center, because running through the center may cause problems for what I have in mind next. Okay, so now that we have these sets of hoses, we want to make sure that they play nicely when we actuate the kickstand. And what I mean by that is that there's a strange kink there. Perhaps I have too many points. No, I think it's just the way that it's interpreting the spline. Either way, so yeah, that's one of the things that you don't have to deal with if you use a Bezier spline. You can have really fine control over all the curvature, but you got to do it manually. Okay, so we have our lines there. And what's going to happen is when we actuate the actual kickstand pivot, those lines are going to, well, if they were attached, let me just make them a member of that hierarchy. It's going to make them move and they're not really going to work. So we're probably going to need to have those lines go into the machine so they can run internally, and then maybe bend them or use a bone deformer or something like that to sort of move them in time with the kickstand pivot. That might actually be a good time to add another slider for it. Perhaps we can do that in a future recording, but for now, we should at least route them internally. I think the easiest way to do that is probably to add 2 cuts right next to each other to sort of create that corner. If it was a Bezier spline, you just create 1 cut, but because it's a B-spline, we have to create a couple. Now that we've created it, we can just pull them to the interior of the machine, maybe up a little bit so they get hidden. And then we can select the next pair of points and move them forward a little bit, maybe inward a little bit. We get this idea that the hoses are being routed inwards. We could even twist them a little bit. Twist and scale so that it's not too uniform heading in. And we can do the same thing here. We can sort of rotate these 2 points or scale them relative to each other so that they sort of seem like they're going where we want them to go. So now that the hoses are sort of going up into the machine, we can just sort of tweak their appearance a little bit and change that slightly, and then I think that's it. Maybe in the next episode we can focus on deforming those hoses so that they actually don't do this when we rotate the kickstand pivot. Well, I hope you enjoyed this installment, and until next time, see ya.